Hi everyone, hope everyone is doing well and staying safe. My name is Sitarama Penimetsa and I am the CTO at Candela Technologies. In this presentation, we're going to talk about Wi-Fi access point testing in a continuous integration, continuous delivery pipeline environment, which is how a lot of R&D organizations are operating these days. We'll also talk about how test tools can play their role in a CI/CD pipeline, and we'll also show you a demo of an example implementation of CI/CD automation for Wi-Fi access point testing. Now, over the past decade, Wi-Fi has become an extremely important part of everyone's lives. Wi-Fi is now considered a basic utility, on par with water and electricity in the home and in the office. With remote work and home office automation and over-the-top video content and Internet of Things and many other such modern trends, Wi-Fi is expected to work and work flawlessly all the time and every time with lots of devices connected. Wi-Fi access point testing is complicated with so many different aspects of functionality, scale, performance, stress, and so on that need to be tested constantly. And on top of that, given the rapid evolution of technology and the ever-evolving customer requirements and strong need for time to market, most Wi-Fi R&D organizations are having to operate in a continuous integration, continuous delivery model for development, testing, and product releases. A CI/CD pipeline model can create a lot of churn in the R&D organizations and requires test teams to quickly adapt, automate, and approve product releases across multiple product lines. So, the question here is how to set up a full CI/CD automation to facilitate rapid release cycles while maintaining excellent test coverage and product quality. Now, most of us who have been doing Wi-Fi testing for many years are very used to the concept of setting up test beds for various key product function areas and key customer use cases. Some examples are listed on this slide. Automation for all these types of test beds is in itself a very complicated task. Now, the added challenge is how to fit all this complexity into a CI/CD pipeline, which involves a constant flow of features and functionality through the pipeline all the way from product planning to customer deployments and monitoring. Even though all these stages already exist in a normal model, the interaction between some or all of these stages is often done manually. For example, when the new builds are ready, the QA manager may usually get a notification from the dev team along information about the key features and fixes in the new build. The QA manager will then assign one or more test resources who will then try to figure out which test bed to use for testing, and sometimes may even have to put together a new test bed or have to do a combination of manual and automation testing. The results are then gathered from various QA team members across various time zones, and a report is put together by the manager with performance comparisons across multiple previous builds and node regression issues. While this process works just fine for longer release cycles that span across several months and years, in a CI/CD environment, everything needs to be done in a lot more agile fashion. Automation of as many of these steps as possible will be absolutely key to successfully implement a functional CI/CD pipeline. So the key here is automation, automation, and automation. So the framework we're currently using for CI/CD contains the following key components. The test orchestrator automatically finds new builds, figures out the test plans to execute, and the available test beds to run those tests on, and passes this information onto the test controller. The test controller then upgrades the device in a test, controls the test tools, in this case the Candela LandForge test system, and runs fully automated tests, gathers the results from the test system, compares them to predefined pass-fail criteria, and publishes the results in reports to a visualization tool. The visualization tool can then present a measure of success and comparisons with previous builds to look for regressions. Now this diagram shows a more detailed workflow of what I just talked about in the previous slide. The really cool part of this is that pretty much everything you see here can be achieved with a combination of some general purpose Linux machines and virtual machines in the cloud and a series of Python scripts that can control all these elements and the workflows between all these elements. Platforms and tools like GitHub, JFrog, TestRail, AWS, and other tools can be used to create fully automated and integrated CI/CD automation. Let's take an example of running a simple test case on an access point DUT that is connected to a cloud controller. The test case is to connect a few stations to the AP and make sure the connection times meet the pass-fail criteria and both the AP and the cloud controller register the connections. To run this test scenario, a Python script can be written to automatically check for and pull the latest builds from the repo and load them onto the AP. Once this is completed, the script then can pick the right testbed to use and send a command to the Candela LandForge test system to initiate the client connections and measure the connection times. The script can then also log into the serial interface of the AP and the interface of the cloud controller in AWS and check to make sure the client connections are registered. The script can then also gather the test results from the test system and push them into an automation tool like TestRail for visualization of the results. All of this can be achieved using readily available platforms and tools. Here is a testbed diagram that shows the connections between all the testbed components. In the interest of time, I'll not go into all the details here, but if anyone is interested in knowing more and seeing a detailed presentation, please let us know. Here is an image of a simple AP testbed. This testbed is designed to create a fully automated lights-out lab with an RF enclosure, programmable power switch, webcam, the Candela LandForge test system, serial interface connections to the DUT, and a lot more, with a goal to configure and control all components of the testbed remotely. We can also create more complicated testbeds as a part of CI/CD automation for advanced test cases like mesh, roaming, scale, stress, performance, and a lot more. So now we show you a quick demo of an example of a CI/CD automation implementation that we have done for some of our customers for testing access points.
So today I'm going to show you a subset of the CI/CD pipeline. The circle in green here are the components that we'll be concerned with. So at the start of my demo, the test orchestrator has already done its job. It's looked in the build artifact system. It found a new image and it created a work item that we will use to execute. So the testbed controller will ask the orchestrator, do you have any new work? And yes, indeed, new work will be found. The testbed controller will then tell the LandForge to run the test. The device under test will do its job. And in the end, we'll get a result. So this test will take a little while to run, even though I'm using an abbreviated version of the full CI/CD in the interest of time. And just to reiterate what Sitarama showed, this is the test bed we're using, or very similar to that. So we have the LandForge at the bottom, we have an AP, which is the device under test, and we have some auxiliary components to help with remote access and so forth. So I want to stress that not only can you use this for CI/CD, which is basically an automated system where you set it up and you just kind of look at the results every now and then and go and look into bugs reports and such like that. But you can also use this as a manual testing where you log into a remote test bed, reserve some time, and run specific tests that you're interested in. So this window here is a VNC connection, a virtual desktop connection into the testbed controller. So the screens on the left are the testbed controller, and it is connected to the LandForge desktop, virtual desktop on the right. So this window is the LandForge desktop. The big window here is the LandForge GUI. That's our command and control application. It will visualize the existing test, orchestrate driving the test, generate reports, and so forth and so on. So in this case, the LandForge is represented by the green square here. The device under test is the blue system. The curved line is showing that stations are connected. So this is kind of an idle state left over from the previous run. And then I'll be starting this. So the test controller script, this is the script that is going to pull the orchestrator to ask for a new work item. So it calls this and it passes some passwords information, and here's the URL to use, and so forth. So this script would be customized for your particular scenario, your particular lab. I think that most likely you would be able to use a lot of what we have here, but at the same time, it's not a huge script, and it could be written for your custom scenario. So when I start this test, it's going to download some stuff. It's going to stop the LandForge GUI, which will be automatically restarted, and then it will get on about doing the test. So I'm going to go ahead and click enter and hope that things work well. So I tried to add some comments in the script here to explain a little bit about what's going on. You see that the GUI was stopped and now it restarted itself. We do that to get the system to a known state. We may in the future add some additional initialization, but for now, then this is sufficient for our current test cases. So we've pulled down the image, and now we're upgrading the DUT. So we have some scripts, some Python scripts that effectively run expect. We're logging in over the serial port of the DUT and making requests for it to do the upgrade. You could also do this over SSH if your DUT does not support serial connection. We find the serial is nice because it's good for gathering low-level debugging information if indeed the regression test finds any problems. So in this case, we're not using the cloud controller. It simplifies the test case, and in this case, we have not fully set up the cloud controller for this test bed. So some initialization, we'll be rebooting the AP again. Okay, so the AP is back up now, or it will come back up shortly. And at this point, we're starting the automation test. So this is the fast one, which takes, it depends. I've abbreviated this time so it's quite fast, but normally it's maybe a 30-minute test. We have another more substantial test that takes 3 to 4 hours, and all this is configurable and individual tests can be added or removed from your scenario. So the script on the left here is causing the GUI to do these actions on the right. I am not driving the GUI automation. These windows are popping up due to commands that we send over TCP/IP socket into the GUI itself. So we have basically a command line interface into our GUI. So back here, you can see the stations that we're creating. So this test is going to create 32 stations on several different LandForge radios and have them associate to the access point and run a throughput test. So at first we just do a single station test, and this happens to be a 2.4 gigahertz radio. So the overall throughput for the first one is relatively low. You'll see that it's in the 125 meg range. For the next iteration, we'll bring up 5 stations total, which will bring up an additional 2.4, as well as some 5 gigahertz radios. And now because we're running 5 gigahertz, then our throughput is going to be a lot higher. So this test will continue until all 32 stations have been brought up. It's a configurable set, so we bring up 1, 5, and then we'll bring up larger quantities after that. We run the throughput test at each time. We're gathering a lot of other statistics too, including latency and gathering logs and more than I can go into in this demo. As with all of our stuff. If you want details, please ask. We'd be happy to go into great detail on any of this. So while this is running, another thing we're doing is we're watching the logs. So let me show. See if this. So this file is being created on the file system by looking at the serial port output from the device under test. So in case any problems are found, like kernel panics or firmware problems or things like that, then this window would show that. And this is just for demonstration purposes. So normally this file would be just gathered up as part of the end result of the CICD test. It'll be packaged up and uploaded back to the test orchestrator for display and long-term storage. So I'll show you that towards the end once the test is completed. So at this point, we brought up all the stations. See, they all came up. They have IP addresses, and we're running traffic once again for the final test of 32. In the non-abbreviated version of this, I actually bring up 228 stations on this access point. So each of the LandForge radios, the 11AC radios, can do 64 virtual stations each. So even with a relatively modest system, so one LandForge with say 6 radios in it, you can create a very large number of stations to really stress test your access point. And just bringing up a bunch of stations and driving traffic can flush out a lot of bugs. We also have many more advanced tests where we're doing like station resets while the traffic is flowing and doing a mix of TCP and UDP and web traffic and other such stuff. So the test is completed. You see here that we're uploading the results back to the test orchestrator. So the test orchestrator is another script. And remember, it asks for new new builds to test on the access point, but it also gathers up and deals with the results from the test beds. So let me show you some examples that I've previously done. So this is the Ferndale 01. So this is our town is called Ferndale, and this is the one down in our lab that I've been running the test on. Now this is a longer test. It was run a week or 2 ago, or 3 now. And it's doing like a 4-hour test with so throughputs, testing throughput with single station, upload, download on different bands. This is a capacity test and some other things. We have a bunch of subtests in each one of these test cases. So the total pass was say 3,000 and such, and then the failure was around 1,000. The truth is this test bed is not well tuned for pass fail. So we're not trying super hard to get these failures down. A lot of them is like the station connected in 32 milliseconds instead of 31 and things like that. We are looking at the logs. So we found a couple of crashes and a couple of warnings. And so if this was your system and your build, then you would probably want to click into here to find out some more information. Again, this web page is generated by the test orchestrator that we wrote. You do not have to use this to make good use of the CICD, but you might want to. So another option is to drive it with something like test rails that would take unit test and provide long-term storage. Something like Jenkins may be familiar to some of you that I think would take a similar role. So anyway, so you can click into here, you can see the details. You could go into the individual test case. These PDFs or web pages are what we generate as part of our normal manual as well as automated test. So these are available. PDFs are generated to pass off to third parties easily, things like that. One final thing I wanted to mention before we go to Q&A. We have a programmable power controller in all of our test beds. And so when you are up late at night and your system dies horribly and you don't feel like driving down to the office, or you can't for other reasons, then we can use this power switch to gently switch everything off and then switch it back on again. So this is a nice little feature. We're including that. And of course, you can get these elsewhere, so this is not magic. But we find it useful and we include those in our test beds. So let me go back to show you the slides once again. So this was our test bed that did all of this. And again, this was the part that I showed you. Cloud SDK, Cloud Controller, we did not include in this, although it can be done. The test orchestrator, I did not kick off, but it's waiting in the wings. And the build artifact systems are running along their merry way, even right now, probably creating new builds.
Now, the question is, how can all of this fit into your existing automation framework? Candela can help you with any portion of this framework for your ongoing projects, or help you create the entire framework from scratch for your new projects in which you may already have plans to revise and modernize your automation framework to align with the CICD model. Candela can provide you just the test equipment needed and help you integrate your test tools into your existing automation framework so that you can leverage our already existing hundreds of automation tests. Or Candela can integrate your DOTs into our automation framework, configure your DOT through our automation, and run tests and create reports. Or we can create the entire CI/CD framework for you, where Candela can access your build system and create full CI/CD automation, including test orchestration, test control, result visualization, and more. While you may come across test equipment product companies that provide good test tools but not good ways to create the entire automation framework, and you may come across test services companies that can create the frameworks and do the testing for you but may not have proper domain expertise or knowledge of test tools, Candela, on the other hand, is uniquely positioned to provide you both the test tools and the services needed to create highly efficient, comprehensive, customized, super fast, and highly affordable automation frameworks for our customers. Please do contact us at sales@candelatech.com if you have any questions or would like to learn more or see a demo of our CI/CD automation implementation. Thank you for your time.